In Mosfet scaling, there are so many short channel effects. For example, channel length modulation, drain-induced barrier lowering, velocity saturation, and ballistic transport. But in this lecture, I will explain channel length modulation. And this is one of the specified articles and it requires multiple references to my previous lectures. In channel length modulation, referring to this saturation region of Mosfet, Id-Vds characteristics, the length of inversion channel decreases for higher values of potential difference between drain and source. In response to this effect, drain current in saturation region start increasing with VDS this way, which I will explain on the next page. There will be slope in this region. The second point, the output resistance of this device, this is NMOS is shown here, and R0 is the output resistance between D and S. This output resistance will decrease. In my previous lectures about current voltage characteristics and formation of inversion layer, I explained in saturation region, Id-Vds curves are parallel to VDS, indicating zero slopes. And zero slope means output conductance of this device is zero. Or in another word, the output resistance of the device is very, very high. You may say infinite. And this is the expression for drain current in saturation region. You can see drain current does not depend upon value of VDS, entirely depends upon VGS. And this is the potential difference between gate and source. We can say one thing, in saturation region, this device is working as an ideal current source. And in fact, this is simply an ideal picture for smaller values of drain to source potential difference. This is the cross-section area of inversion channel under effect of channel length modulation. This is source, drain, and this is P substrate, this is silicon dioxide layer, and this triangular shape of inversion channel is at pinch-off condition where VDS is equal to VGS minus VT. When the potential difference between drain and source is increased in saturation region beyond pinch-off condition, then the length of inversion channel decreases and the tip of the inversion channel recedes back toward the source region, and a gap is formed between tip of the inversion channel and drain region. This is the gap, and the whole region is populated by immobile acceptor ion. This region is called depletion region. When the length of inversion channel decreases, that means overall its resistance also decreases. Naturally, current must increase, and this is the meaning of this effect, channel length modulation. And this is the overall picture of channel length modulation, where when VDS is increased beyond pinch-off in saturation region, current increases, or you can say in saturation region under effect of channel length modulation, drain regains its control over drain current. And this effect is more pronounced for the devices with shorter channels and deeper drain region and thicker oxide layer. So overall, this is a picture of mechanism of channel length modulation under effect of higher potential difference between drain and source in saturation region. This is the label diagram for inversion channel of length L under effect of channel length modulation. This is source, drain, P-type substrate, and this triangular shape of inversion channel is for pinch-off condition where VDS is equal to VGS minus VT. When VDS, the potential difference between drain and source, is increased in saturation region beyond pinch-off condition, then length of inversion channel reduces, and this is a reduction in length by delta L, and ultimately the length of inversion channel remains is L minus delta L. And this part where there is no inversion channel is populated by immobile, etc. And this is depletion region, and this is neutral p-type substrate. Because of potential difference, we have one longitudinal electric field along the channel, and direction of electric field is from drain to source region. Electrons starting from source region under effect of this electric field will gain higher kinetic energy till they arrive here. And these electrons are called hot electrons. And these hot electrons will be swept across depletion region by this electric field, and they will reach toward the drain region. And this is all about the mechanism of working of hot electrons. And in this condition, because of their nature, their drift velocity will not be proportional to the electric field. In the next section, let us derive the expression for drain current under effect of channel length modulation. For MOSFETs with longer channel length, effect of channel length modulation is explained by using Shikman-Hodges model. And this is the modified expression for drain current with channel length modulation. And this is the effect over here. Under CLM, length is decreased by this much amount. So we have just replaced this factor denominator. And after some mathematical modification arriving at this point, and this factor entirely depends upon potential difference between drain and source. So putting this factor equal to this factor, you may call this factor as a fudge factor, including this fudge factor here. This is. So this expression is the modified expression for drain current with channel length modulation factor over here. This is called lambda. This lambda is very important parameter. In fact, this is technology related parameter. And this depends inversely proportional to channel length. So this is the modified expression for drain current under effect of channel length modulation, and this factor takes care for channel length modulation. And this is a modified current voltage diagram for MOSFET considering channel length modulation. And we see this factor increases the slope of these lines. Previously it was 0. This was the earlier condition. And these lines show absence of channel length modulation. And this is the slope. And this slope is because of channel length modulation. At a particular value of VDS, negative value minus V, this drain current becomes 0. Putting this value over here, and we get one parameter. This is called VE, which is inversely proportional to 1 by lambda. This V is fabrication related parameter, and lambda indicates channel length modulation. So this is a modified expression for drain current under the effect of channel length modulation. This factor takes care of channel length modulation. In earlier page, we have seen this factor increases the slope of Id-Vds characteristics. That indicates due to channel length modulation, non-zero slopes of Id-Vds curves in saturation region indicate finite output resistance of MOSFET. We will calculate output resistance of device. For the time being, this is the expression after modification arriving at this vision and splitting in two parts. This part is because of channel length modulation. And expression for ID, this is the expression for ID, and we can find quiescent drain current at constant or DC potential difference between gate and source. This is the expression for quiescent drain current. Now we define output resistance of MOSFET. This R0 is the derivative of current with respect to potential difference at a constant value of VGS. So this is the expression. This is the expression, and by putting the value of V 1 by lambda, so this is the final expression for output resistance of MOSFET. And this means we are including channel length modulation. Let us conclude this chapter. So this is a modified expression for drain current, which includes the effect of channel length modulation, and this part of drain current is because of channel length modulation, and this is the expression for output resistance of MOSFET in terms of V and ID and in terms of lambda and ID. Let us see what happens in absence of channel length modulation. In absence of channel length modulation, lambda is 0 and VE is equal to 1 by lambda. That's why V is infinite. First point, this part of drain current because of channel length modulation becomes 0, and output resistance in absence of channel length modulation becomes infinite. That indicates Id-Vds curves become parallel to VDS axis. This way, this is VDS and this is ID and this is the position. When this line is parallel to this line, indicating R0 is equal to infinite. And this is all about channel length modulation for MOSFET.